Hello YouTube, RJ. Hey, we're back working on the high voltage power supply. We're bringing this thing to an end. I've got everything built. Where we were last time is I had put in the heat sink and the power transistors. I had put the little regulator chip in and I had wired up some stuff. At this point, I went ahead and added the other tip 50 over here that handles the current control. I've got my 8.2 resistor, and then it's wired in series with a multi-turn pot up here, which this one right here, which then lets me add more. I can never get below 8.2, but I can get more resistance. So what that does, that limits us down to 100 milliamps no matter what from that fixed resistor, and then we can lower it by cranking up some more resistance in that circuit. The next thing I've got to do is go ahead and box this thing up, hook it all up to the equipment, and we need to run through and verify whether it works, whether it does what we expect, and does it meet our specs. Are we happy? Is the ripple low enough? Does it do the current we need? Does it do the voltage we were looking for? What's its capacity? Where's the voltages fall out? How much current? What's the ripple? Is it noisy? Is it quiet? Does it function correctly? Is the meter fairly accurate? Already went through calibrating it. I'm pretty happy with it, I'll tell you now. Because once I button it up, I can't get to the calibration pots on the back of the meter here. I'm pretty happy with it. I think you will be too, and we'll let you see how that came out. Let me get to buttoning this thing up. I'll come back and we'll give you a view of the finished product and see what you think of it. See if it can meet your approval. I hope it does. Okay, before I unveil the finished power supply, I wanted to show you how I made the DIY circuit board here in the lab. This is just a single-sided circuit board that I spray painted with flat black paint, allowed to dry, 12, 24 hours, whatever. And from there, we're going to make a circuit board real quick. Okay, then I go into dip trace and design the circuit board, just a simple single-sided circuit board. Then I go into the print preview, and from there you can actually save out an image. I went and removed everything but the traces and pads. So this gives me this image right here. And then we need to change this because of how we're going to do it. So, okay, so this is not the finished board. This is when I first started laying it out. I made some changes. But you can see what I've done is I've mirrored the image and I've inverted the colors. And the reason is I'm going to put this board now on the laser, and I want everything black to be lasered. So everything that's black will be lasered, and actually what that will do is do the invert of this picture. It will take all the black paint off of everywhere that is black now and leave me with just black paint where the traces are, and that will protect the copper from being ate away when I put it in the etchant. Okay, then I pull out my 421A liquid 10 from EG Chemicals, take one of my little foam Q-tips that you see me using cleaning boards all the time, and I wipe it over the copper traces repeatedly and let it sit a little and wipe it some more. And it applies a light coat of tin to it, which solders very easily and also prevents any corrosion. Okay, and then now you can see the finished board with a nice, tin plating over the traces to make it very solderable and no corrosion. And with that, I'm ready to go. And so then I just attach this to the back of the meter, and you end up with something like this. Now this gives me a very nice board to work with. Traces are on the back, keeps the high voltages away. As you can see, the multi-turn trimmer pots I have there to tweak the resistances to get the meter to read accurate. And so that's how I did it. Okay, I want to take a quick second to show you a little something I put together here. I didn't have a way to load the high voltage power supply. Now I have my programmable load. You've probably seen me use that in previous videos, but it can't go up into the hundreds of volts. It can't handle that kind of voltage. So I needed a way to put a load on this thing, and I needed kind of a variable, be able to change it at least some to get some different loads at different voltages. So I came up with this. I found these 1 kilo ohm power resistors, 50 watt, a pack of 5 of them on Amazon for, I think it was $9. Wasn't too bad. So I ordered them, and what I did is I just cut me a little piece of hobby plywood with the laser cutter real quick. And I used that UV glue that you might have seen me in, a couple videos back in my AliExpress haul video, where you put the glue on and use the UV light and it hardens instantly. I went ahead and glued them on, took a piece of, let me get up a little closer, you can see a little better. Took a piece of copper wire between them in a pattern, zigzag pattern. And so I can hook to one end of this, and I can hook to different spots to put different resistance loads on the power supply. Looks like it's going to work really, really well for what it is. I mean, it'd be nice to have a actual load like my other one where I could say I want so many milliamps and no matter what I do with the voltage, it would stay there. But with this, I'm able to load and test. We're going to be able to do some tests on the high voltage power supply, look at ripple, whether it meets my specs, that kind of thing. So wasn't going to be able to do too much without some way to load it. So just kind of a quick, cheap, dirty way to make a high voltage load. If that's something that'd be handy for you, I'll put an Amazon link to these resistors in the description of the video. That way, if you decide you want to do something like this, you'll know where to find them. Okay, let's get back to doing other things. Okay, I've finished it. I've closed it up. As you can see, the case got a new paint job on it, and I think it looks pretty nice. I'm really pleased with the front panel. I hope you are too. Let me give you a little spin around here, make sure you can see it. You can see the laser lettering and such marking that I did, and then faceplate on the meter. I'm really happy with the way it turned out. I hope you are too. And so the big thing now is, let me get this set up on the bench here with a camera where you can see what I'm doing. And we'll hook it up with some stuff and give it a run through test and see how it works and see what our parameters are, and take a look on the scope with it and see if it's got much ripple under a load. So I got a few things on the bench to set up, a couple cameras to set up, so I'll be right back with you. Okay, we're back on the bench. I've got my little load set up to put a load on it. And if you remember, I was trying to get 300 volts at, I wanted 100 milliamps or somewhere around there. Let's see what first of all, let's take a look at loading this thing up. I'm going to load it up to 300 volts. I've got it set for 300 volts. All the current I can get at 300 volts into this load. Understand that it's not all that I can get. I can get 100 milliamps, but depends on the load. So this load, I'm going to get, I think it's about 75 milliamps out of it. And if I drop the load a little bit, it'll go to 100, no problem. So anyway, we're looking at my scope over here, and I am on the 500 millivolt scale, and I can see a little noise from the lab, and I could probably quiet that down if I turn the overhead lights here off, but then you're going to have a harder time seeing things well. So anyway, what I'm going to do is, because I can't really show you everything and get the oscilloscope in clear, I'm going to go ahead and do a screen capture right now of what the bass noise with this unit off, just what it's picking up now. So let me go ahead, hit the print button. Now let's go ahead, and what you've got here is you've got your power, your AC power on and off, and your indicator. You've got the switch that controls whether you're looking at volts or milliamps on the meter. You've got your 6.3 volt AC out here, 2 amps max. It's fused at 2 amps. Current control, voltage control, and then you've got your high voltage on and off here, and your high voltage out here. So let's go ahead and power on. And even though we're not putting anything out, we can see the voltage. Got no load on it. Let's go ahead and let's turn it down to say 300 volts. Somewhere in there. I'm from the side. I'm not able to line that up perfectly, but I've got the meter over here, which you can't see. Let's see if I can adjust the camera a little. Sorry about that. Oh, I had it where you could see that. Got the meter over here. It's reading no voltage, no current. Here's our current. Here's our voltage. Let's go ahead and kick on the HV high voltage out. You'll see it comes on, and it doesn't look a lot different on the scope. I'm getting 72 milliamps at 290 volts. Let me adjust my voltage up to 300 exactly. Got with these multi-turns, very good control. I can literally adjust down to 100th if I'm real careful of a volt. So we're around 300 volts here. We're maxing out what we can get because of the current. I'm at 300 volts here. 74. Let's see if I can turn the current up a little bit. There's 75. Okay, 300 volts, 75. Let me go ahead and get a screenshot of this. If you notice, the noise has hardly moved. I'm probably 250 to 100 millivolts peak to peak, which I had before we even turned the power supply on. Let me go ahead and grab a screenshot of that. So that'll go ahead and write that out. And so I'm happy with that. I'll put those up on the screen right now. You can look at them. There's very little difference. So I'm very happy. It's very quiet. So anyway, the way it works is just like any lab equipment. The voltage control is here. I can adjust. Let's see how low we can go. I get 70 volts. So I go down to 70 volts, 50, 67. Meter looks like it's reading accurately. And when I'm down at 70 volts, I'm reading 17 milliamps here. If I want to switch this, I'm reading 17 milliamps there, which is lining up just because of the load we're on. So let me do this. Let me turn off the high voltage. Let's let it bleed down a little. And then what I want to do, I'm going to move this to where I'm on a different leg. I'm on less load, so I'll be able to more current. We'll have more current with the same voltage. Okay, so there. Let's do this. So I'm gonna turn the high voltage back on. We're reading 62, 170, 87 volts, 61 milliamps. Okay. So here I am reading voltage. If I go to milliamps, it goes up and shows me my 61. From this angle, I can't tell exactly, but it is accurate when I've been looking at it straight on. So this is what controls the meter. You control current here. I can control the voltage as high as I want to go until I hit my current limit. See, I can't go up anymore. I'm turning, nothing's happening. Now my voltage is coming down. When you get to a certain voltage, this load is going to hit 100 milliamps and boom, see what happens? It's regulating. I can't go anymore. Now, turn the milliamps up a little. I'll be able to go higher. And I'm going to hit 100 because I'm wide open here. I'm right at 100 milliamps. Bring voltage down. Okay, let's set her about 200 volts just to check our current limiting. Look at the meter over here, I can see better. Around 200 volts, and I can adjust the current. Watch the current over here as I turn it. See the voltage dropping because the current's dropping. Once I start turning the current down, the voltage has to fall to match, just like any lab power supply. It's working totally the way you expect it to work. So what's the max voltage we can get? Well, let's do this. Let's turn this off. Let's take the load off of it. If we take the load off of it, we can see the unloaded maximum. We can get about 400 and almost 50, about 447 or so when I was looking before. So if you're light loaded, you can get around 400 volts, no problem. It's all about how much load you put on it. If I move this back up and load it much less, let's move our load out to where we're using the whole 5K. Yeah, we don't need the scope anymore. I'm very happy with how clean the signal is. Okay, now plugged in the right place. Okay, now I'm getting about 400 volts at 77 milliamps with this load. So I'm able to get close. Turn this off because that looks ugly. Look how much I'm picking up on the bench with this probe just laying here. I can get about 400 volts at about 75 milliamps. You come off 400 volts and my current goes up to, by the time you get to 300, you're at 100 milliamps. I just don't have a good load that lets me pick any load I want, unfortunately. This is the best I can do for this kind of voltages. But hey, I'm real happy. The signal coming out of it's pretty darn clean. I don't really detect anything above what I'm picking up ambient before the meter's even turned on. And that's under a load, loaded up heavy at the highest voltage I can pull at the load that I'm on. I've tried a couple of different settings. I won't sit here and do 30 minutes of playing with each resistor. It actually looks like it's quite well performing, so I'm very happy with that. So anyway, I hope you're happy with the outcome. I know I am, extremely. Couldn't be happier. It's going to be a handy device to have around for the lab when I need high voltages. I don't really have anything that'll do that kind of voltage. And when you get about 60 volts, all my bench stuff is pretty well tagged out at that point. That's what's really nice with it being able to get down to about 73 volts is I don't have much gap. I can go 60 volts supply, current lab supplies DC. Now I can go from 73 up. And so I've got a pretty good range of power I can supply on the bench. Really happy with the new way of making the faceplate. I did not clear this. It would have popped and got a little darker and looked a little nicer with clear. But I really kind of decided I want to keep kind of an antique look, and I think that looks more antique. I just decided not to do that, but I'm really happy. Something to remember, I was showing you the laser cutting this. There's no paint to damage on this. Other than the paint, the eggshell paint on the front, this dark is actually, the aluminum has been made dark by the laser, and it's actually etched in here. You can feel these when you run your finger across them. They're etched in. There's nothing to take off. Your lettering is not going to come loose. So that's kind of a pro over stenciling. Kind of like the way that worked. Might be able to do some other colors and do some other things and make some really nice panels for like radios and stuff in the future. So kind of a neat thing to have in the tool bag when I need it. Hey, thanks for watching, guys. I hope to see you in the next video.